Welcome to CyberOptics booth here at Semicon West. I'm joined by Dr. Subodh Kulkarni. Nice to see you again.
Good to see you, Trevor, as usual.
Yes, different setting, of course, but you've got a couple of very important and unique products for this market. First of all, we'll talk about is the wafer sense product that you have. Does a number of functions. Maybe you can describe it.
Sure. So wafer sense and reticle sense is a very important product family for us. We have been investing in this area for many years now. What essentially they are wireless measurement devices. So we have typically a sensor, a wireless transmission element like a Bluetooth or a Wi-Fi, and a lithium-ion battery, all put together in a tight form factor on a wafer or a reticle. So it looks like a wafer or a reticle, feels like a wafer or a reticle, but it's really a sensor.
Sensor.
So what we are doing is we are going inside the tool and doing different kinds of sensing remotely, and then passing the data in real time to the process and equipment engineers, and then they use that data to understand what's going on inside their process tools.
Okay.
So we have 7 applications right now: leveling, teaching, vibration, particle, humidity, gapping, and resistive.
Right.
So all those applications are very different. I mean, for instance, leveling is going and measuring the level of a particular substrate. A particle, as the name indicates, we go and measure the number of particles of certain dimensions. Humidity is measuring humidity.
Humidity,
The 2 new exciting products we are showing at this show right now are both in the teaching sensor area. So in teaching sensor, we are essentially teaching the robot how to handle the wafers, where to hand off the wafers.
Right.
So we are basically the eyes of the robot.
Right.
So we go on the robot, we are helping the robot understand where to take the wafer, when to hand off the wafer to the next step, and so on.
Right.
So in our typical teaching sensor, we have been selling for a few years, and it's a very popular product for us right now. We have only one camera, and it's a black and white camera, but there's an increasing need with the increased complexity in the front-end semiconductor fabs that they wanted to see both sides of the robot and what it is doing. And that's why we developed this, what we call the next iteration of our auto teaching sensor. We call it ATS2. It's got 2 cameras, one on the front and one on the back. And here's a product right here.
Good example, yeah. It looks like a wafer, but same wafer size, so it's got a camera on each side.
So it looks like a wafer, feels like a wafer, same height, same weight, same dimensions, but it's a silicon carbide substrate with cameras, Bluetooth or Wi-Fi, and lithium-ion battery. So we can go wirelessly on the robotic arm and find out exactly where the robot is, and so it can do the teaching.
So the dimensional data that this is giving to the robot, what accuracy is that working to?
So very, very tight accuracy, and in the spec sheet we go into that, but we are down in the micron type ranges. So we teach the robot exactly where it is in the a few micron type accuracy settings, which is good enough for that particular application.
Excellent. Okay. And you do gapping. What is gapping?
So gapping is our most popular wafer sensor, actually. That goes typically in the deposition system, but it can be taken in other areas too. But in the deposition system, you usually have a plasma CVD setup, and plasma is struck between 2 big electrodes, and they need to know the spacing between the electrode, how parallel they are. Any non-parallelism between the electrodes can cause severe uniformity problems, and that's a big problem. So our gapping sensor essentially goes between the electrode and does 3-point conductance measurement effectively, and we precisely quantify the gap between the electrodes. Once we have 3 points, that defines a plane, and we can tell them exactly where the electrode is. So that becomes very important for them to control the deposition process.
Okay. And then finally, the other piece you do is resistance. You're testing the resistance on the...
So resistance is one of the new applications we got into last year. It typically goes in your electroplating system, so that's where after the wafer is typically, the front end is done, you want to do copper plating to create the contacts. Right now there's a big problem in the industry where over time the electroplating system drifts, and the resistance of the copper uniformity changes over time. And right now there are crude processes that are done to see whether the electroplating system is under control or not. For instance, they run some blank wafers after every 5 wafers, or they actually clean out the system completely, and it's an acidic bath.
A big job.
So it's a big job. So it becomes very inefficient, very time consuming, yields are low. So what our resistance sensor does is goes in after every few wafers, and within a minute we can tell them exactly what their resistance is between the various point contacts, so they know that the system is still performing, so they can keep processing the wafer. So again, in general, all of our wafer sensors basically improve the yield and productivity of the processes, and that's what the resistance sensor is doing in the electroplating system.
Okay, great. So you have another sensor here, this one. What is this one for?
Sure, so this is a new sensor we have, we call it ATSR, and as you can see it's in the reticle form factor with multiple cameras.
Yeah.
So it has 4 cameras on the edge and 1 in the center, and this becomes very, very important in the lithographic area where they are handling the reticles, and they need to know precisely where the reticle is. One of the most sensitive processes in the semiconductor front end right now is what's called extreme UV lithography.
Right.
That's what's defining the transistor, and it's extremely this is very expensive piece of equipment, more than $100 million a piece.
Gee.
And they need to know very precisely where the reticle is at a time and where the robot is handling it.
Right.
And ATSR is really designed to help those kinds of processes where the reticle is being used, and to help them understand where exactly the robot is within the reticle handling system.
Right. So a very important piece of equipment.
These are critical pieces of equipment that are controlling the front end fabs right now.
Okay. Well, it's fascinating to see some of the inspection systems that you've got here for semiconductor, but you've also got some other types of inspection systems for the semiconductor process specifically. Can you tell us a little bit about that?
Sure. So we talked about wafers and so far, but we have another bigger chunk of our CyberOptics business is what we call the MRS, multi-reflection separation, 3D non-contact optical sensing that we use for things like SPI and AOI, and that's why we are in the SMT shows and we have talked about it a lot.
Yeah.
But we also use the same technology for semiconductor inspection applications, the back-end inspection, like the IC package inspection, or many other kind of semiconductor inspections in the back-end area that need optical sensing technology.
Right.
Typically, those are much bigger pieces of equipment, so we don't bring it to these kinds of trade shows.
Yeah.
But our differentiation there with our MRS technology is speed and resolution accuracy at the same time. We are generally faster, more accurate than conventional optical technologies. So we are getting tremendous traction with the MRS sensor and MRS inspection systems.
Good.
And semiconductors is a big chunk of our business right now.
Right. Excellent. Well, you're obviously very active and very busy in it, so I want to thank you, Subodh, for giving us a walkthrough on some of these products today.
Thank you, Trevor, as usual.